Hello, Keith Rucker here at VintageMachinery.org. Guys, today, over here at my 10EE Lathe, this has been a really long-term project now, and it's been kind of sitting idle for a while, and I did want to kind of give an update because we have made some progress on it. This is a project I've kind of, like I said, been working on a little bit along, and just bringing you up to speed, and for those that may not remember, I acquired this lathe quite some time ago. The electronics that were in here originally were all gone. The original electronics were. This one basically was a motor generator set. For you don't know, these have a DC, a direct current motor in them that powers it. The direct current motors do have some advantages over the alternating current motors in that they're very controllable. You can get a lot of variable speed out of them, and you can keep constant torque at these different speeds. But the DC motors that Monarch used were very specific for these lathes, and they were kind of unusual in the way they work. I'm not an electronics person, I'm not an electrician by any means, and when you get into this DC world, it's even more foreign to me. So I don't know, I can't explain all the details like I probably should, but I will just say that the motor that's in here is not your off-the-shelf DC motor that you can just go buy a DC controller for, pop it in here and roll. It's a lot more complicated than that, unfortunately. Fortunately, there is documentation out there, and through the help of a viewer up in the Minneapolis area who doesn't want to be identified, I'm not going to mention his name, but he has been really very helpful in basically kind of reverse engineering what needs to be in here from an electronic standpoint. He was able to find some of the original schematics, and guys, remember this lathe was built in the 1940s, so the electronics have gone a really long way. It had a alternating current motor that went to a direct current generator that generated the direct current. Then there was some, I'm going to call them electronics, but this actually predates electronics. In fact, this particular lathe even predates the tube technology that Monarch had in some of the later models, but they were able to do some things to control the speed and what have you in there. And basically, we developed a modern set of electronics over here to do what we needed to do. One of the things that's really confusing about this particular lathe is normally you have your DC current going to your lathe, and you also have a field current that is used for varying the speed. This particular lathe actually has two sets of fields. So instead of 4 wires, there's 6 wires going into it. And again, I can't explain all of it. I do know that on the fields that it's like half the fields, or 2 of the fields, or 1 pair of the fields, I guess you could say, control half of the speed range, and then it like takes it up to a certain point, and then they max out, and then a second set of fields come in and it takes it to the rest of the field range. And it seems like on the second one it's actually reducing I don't know. Anyway, it's really complicated, and we've had to do a lot of trial and error, a lot of testing things, and to get all this working. And then there's some contactors in here that, for different functions and stuff as well. I'll kind of real briefly go over this. I'm not going to go into it in detail because I don't understand it well enough to go over it in details, but we'll go over it in just a minute. But I do want to just kind of show you. I will say this. We've got it working, and it's taken a long time to get here, and that's been my fault because I just haven't had the time to sit down and do this. Anytime I work on this, I basically have to get on the phone with the gentleman that's been helping me with it, and he has to kind of coach me through everything. There's been a lot of testing, a lot of reading meters and different things at different speeds, and then going in there and tweaking the program and then trying it again and back and forth and back and forth. But I think we finally got it where it's more or less working. We've still got some room for tweaking, and I think we will be doing some more tweaking, but I'm to the point where I'm ready to put the electronics in the lathe, and that's what I want to work on today. This panel over here, I'm going to show you that real briefly, but it's going to go up underneath the bottom of the machine down here. There's a tray that pulls out in here. This is what they call the works in a tray model. We've still got the original tray in there. I'm going to mount that in there, and I've got to rerun all my wires back through the lathe down here to get all that hooked up. But before we do, let's show you how it works and kind of give you a little update on things where we are right now. So one of the kind of neat things about this setup that we've got here is even though we've got all new electronics that are controlling everything on the inside of the lathe, on the outside of the lathe, we've pretty much been able to maintain all the original controls and everything just like it was originally. So from an operational standpoint, it's just like an old-fashioned 10EE, but we got modern electronics powering everything. We do still have the original DC motor in there as well. So on this lathe, you've got the power switch right here. When you hit that, it powers on, and you can see when it does, all the lights start coming on over here on my control board, and that's just letting me know things are working over there. This will be on the inside. You really won't be able to see it, and I'm going to go over this here in a little bit in just a minute, but the controls on the lathe itself is basically you got the on-off switch. This knob here, when you move it forward, it's a drum switch, that's forward and reverse. And then there's a knob right here that is your variable speed. And basically on this, we've got it on the inside just chained and geared sprockets and chain actually to a potentiometer. Oh, actually it's gears, it's gear driven, but it's going to a potentiometer in there, which basically gives us the variable speed. Interestingly, on the original setup, it had a big rheostat in there, which is basically a potentiometer, but it had two different sets of whatever on the inside, electronics on the inside. So when you turned it, it was not turning just one potentiometer, it was simultaneously turning two. And they were wired up in such a way that was controlling the two independent fields that we talked about before. Unfortunately, wasn't able to use that original rheostat, but we got a single potentiometer in there, and through the logic and control and the programming that we're able to do over here in the electronics, we're basically programming to make those ranges as they need to do. So we've got the power on, and when I turn the knob over here, you'll see it is going forward, goes back to the middle, that's stop, and then reverse. So you see that. Now we'll go forward again, and here's my speed control. As I turn this up, we got a tachometer here telling us what the speed is, and it will just let us control it electronically. It also has a set of back gears in the lathe down there, and you can control that here from originally, and that really wasn't electronic, that was more just switching a gearbox in there, but it's got two ranges of speeds for that motor. So normal high speed, but then there also is a set of back gears that will kind of get you slower speeds if you want to use them through a gearbox that's mounted on the motor. And again, that's all original. We didn't really change anything from that. But I wanted to show you that working. Let me just kind of real quickly, and again at a kind of a high level, I want to show you what we've got over here, and I'm just going to say up front, I'm not an electronics person, I can't explain it all, but I'm going to kind of give you a high level look at what we've had to do over here. So this is the electronics that we have that controls everything, and most of the stuff was just off the shelf, things that we were able to buy. Although there are a couple of custom components in here that was put together by, the gentleman that helped me do all this. But we've got some contactors over here. This is basically your power, forward, reverse, forward hold, and reverse hold. So just some contactors in here to let you be able to control things. There's a timer over here. Again, I'm not exactly sure what all this stuff, most of these are just control relays over here. This little electronic box right here, this is a Arduino, which is basically a computer. So it's got a computer chip in here. You can program this thing. You can actually plug a USB cord into it, hook it up to a computer, and there's literally a program that he wrote that does a lot of the control work, that kind of programs everything. And you can write your own code for it, which is exactly what he did. He's got this thing set up where there's variables that we can change out in there, what have you, to be able to tweak things and fine tune things. Yeah, up here, this is just a little display that we were using when we were troubleshooting things. It's giving us some information that comes back off of this Arduino board. From a practical standpoint in operation, I'm going to leave it in here just because it's handy to have, but really not necessary. It's just a little bit of a display that kind of tells you some information that makes things a lot easier while we were troubleshooting and programming it. If you flip this thing around, on the other side, we got more electronics and more control stuff. Let me get it flipped around here. So on this side, again, we got some, there's some motor starters down here. This is basically a DC controller. And I'm trying to remember who made it. I don't remember who made it. But anyway, it's a Parker. Yeah, Parker 514C. And this is basically your DC control stuff that controls the motor. Unfortunately, this is out of production. They don't make these anymore. You can still get them. They still support them. But for the motor that we're running, to my knowledge, and according to research we've had, this is really about the only controller that will work with that motor. But to complicate it, remember I told you there's two sets of fields. We've also got this DC controller up here that actually controls the other set of fields. This one is one made by KB Electronics, this up here. So it really takes both of these to be able to do what we need to do. Just one out of the box wouldn't do it. We got some fuse blocks down here. This little interface, this is basically a KB-TC interface to go between here and here. This board, he actually designed and built specifically for this application. This was a custom built board that we needed just to be able to do this, and he designed that, built the board for me and everything else. I want to say he did another board on the other side as well. I can't remember. But there is some custom stuff. Most of the stuff is off the shelf, but there is some custom stuff that we did in here. Now, I've had a lot of people ask me, hey Keith, when you get this going, will you share the plans? Will you make these available for other people for doing 10EE conversions, etc.? And unfortunately, the answer is no, I'm not going to do that. And the reason I'm not going to do that is because I don't know enough about how all this stuff works to be able to support it, to be able to answer questions or anything like that. And the gentleman that was helping me with this, while he has been very gracious to help me with it, he has said, you know, he really doesn't want to get into where he's out supporting this stuff. And what we have found out through the process of doing this is that over the years, Monarch had multiple variations in the lathes that they built. And even within a year, depending on the features that you got in that lathe, there were other electronic things that were going on. So this is not a one-size-fits-all solution. This is a solution for this particular 1940s era, works in a drawer model lathe with the options that I have on it. And you know, if somebody else comes along and they have one that's a little bit different or a little bit newer, a little bit older, whatever, it's not going to work exactly like this. It could probably be tweaked and altered to make work, but again, John, the person, John, I mentioned his name, I'm not going to mention his full name, but he doesn't want to support it. So, and that's understandable. He's getting up in age and he doesn't want to have to deal with that. And I respect that. He did do a pretty good write-up on this. If somebody wanted that, with his permission, I wouldn't mind sharing it, but you kind of be on your own. I'm not going to get into a position where, because I can't answer the questions. I have to call him to get help on it. So that's kind of where we are there. And I've got another 10EE lathe, and I think that this board or this setup will work with it, but it is different and it is going to take some changes to be able to make it work. So again, even with going to the slightly older model round dial lathe that I have, it's only got 4 wires on it. It doesn't have 2 sets of fields. It only has one set of fields. So it's probably a little bit simpler, but still there's a lot of stuff that has to be figured out and altered and tweaked to do that. So anyway, that's where we are. enough talking. I'm gonna pull this lathe out. We're gonna unplug it, get it disconnected, and I'm gonna see about getting my wires ran. This is gonna be a pretty big job, tedious work, running wires. I should have made all my wires long enough. I'm gonna probably have to shorten them up and relabel them all so that I know where everything's going and try to get this thing put together. So you saw it work. When I'm done, hopefully it's gonna continue working. Well, I'm back here on the back of the lathe, and this is kind of where a lot of my electrical connections connect from the panel over here to the lathe where I got things wired in. What I'm going to do is I'm going to actually disconnect all these wires. I got a wiring diagram. I just made another one over here on a piece of paper that kind of lets me know which wires go where. But all these wires here have got to be snaked up through the bottom of the machine over to the tray. And to do that, I actually think I'm going to put a new piece of conduit in here. I've got a piece of 1-inch flexible conduit right here, and I really don't have room in here for all my wires to go as it currently is, so I'm just going to add another piece. To do that, I've got a connector that's going to have to go up underneath the bottom here, so I need to drill a hole in this piece of cast iron and thread it for the fitting here to screw up into, kind of like I got in the bottom there. And then from there, we can run our conduit over there and run our wires, this bundle of wires right here up through that conduit where we can reconnect it. So I'm going to disconnect. We'll get the drill out. I think I got to drill an 1 9/16 hole, if I remember right. Anyway, I'll double check that. And this is just going to be tapped for 1-inch pipe tap. This is actually straight instead of tapered. I got a tap to tap that with, so we'll go ahead and get that cut out. Let me go get a screwdriver. We'll pull these wires loose, and we can reattach them later. So drilling in cast iron here, guys. Changed drill bits, went to a sharper bit. That made a big difference. All right, this will get us right at 1 inch. So I finished drilling that out. I can't remember, I think I said the wrong size drill bit. This is 1 5/32, which is the size that we needed for that 1-inch pipe tap, straight pipe tap. Went ahead and got that drilled in, and then came in here with the pipe tap and just tapped this through. Now again, this is a straight pipe tap. Most pipe taps are tapered. This one is straight all the way through, which matches the threads in the fitting. And I've already got it screwed up into the bottom. You can see the piece in there. The fitting is like this right here that will clamp onto that piece of flexible conduit. So this will just kind of fit right up in there like such. Tighten up the screw there and clamp up. So I got the same thing coming up from the bottom. And that's what we will run the wires up through here with. This is be big enough to carry all the wires in there without any problem at all. And that'll give us a direct link down to the tray. Now these other ones that are coming in here go to different places in the machine. None of them go directly down to it. They all go to different things in here. We got different wires going. One of the set, I think this set right here goes over into a box, and then from that box there's a piece of flexible conduit that goes to the tray. But we're gonna be running some other wires through that piece, and there just wasn't enough room for everything in there, but we got it taken care of. Now I need to get a hole over here in the tray that will be mounting the electronics in to mount the other end of the conduit in. Let me show you that. So this is kind of the drawer that pulls out, and again, this is the back side of it, and you got two holes. This one here has the piece of flexible conduit that goes into the works, but I need another hole kind of right down here. There's one over here that's the right size for my fitting, but it's on the wrong side of the tray. We need it over here. So we're going to get a hole drilled kind of right here, and I'll just have two connectors that come in kind of side by side. We're going to mount it where it'll fit somewhere right along in there. And to do that, I think we're going to take this over to the radial drill and get that drilled out, because I'll need an 1¼ inch drill to do it with, and I've got a taper shank drill that will fit in that drill press that we can use to do it with. So we need to drill the hole in the end of this big drawer that pulls out. And I just bolted it over to the side of my table here on the radial drill, so it's going straight up and down. We can drill right into the top. Kind of want to put it right here. And on this radial drill, we can just kind of bring our drill right to where we want to put it at. Lower it down. Get it where I want to put it there. Somewhere right along in here ought to work just fine. So I'll lock that, and we'll drill that hole right there. I'm going to drill a pilot, and then we'll go up to 1¼ inch. I just picked up this big long clamp here from a viewer just a week or so ago. Perfect timing for this job. So let's see, I'm going to go a little faster than that. So we're on about 200 RPM. About 500 RPM. All right, we'll just put it in gear and let her drill through. There we go. All right, let me get my bigger drill and we'll go up a size. Let that one drill through. Just like that, we got our hole. I've got my new piece of flexible conduit in here, plus my old one. Both of them go back into the back. The drawer is pulled out right now. When you push it in, they just tuck right up into the body of the lathe. Nice and out of the way. Pull them back out, and they just pull right back out again. So I think that's going to work just fine for my wiring. I like it. All right, we are making progress here. I've got my electrical panel here kind of installed down in the drawer. This is my wires that we got to get fished up and reconnected. This drawer slides in and out, so it goes in, as you can see, tucked away, and you need to work on it, you just pull it right out, and you got access to everything you need here, so that works good. Happy with that. This is bolted down to this little drawer in the bottom. We got our conduit back there in the back, so I just need to fish my wire out through there and get the stuff where it needs to go. There's two bundles. The big bundle goes back to where we just installed. This bundle here goes back to where we just installed that new piece of conduit. The smaller bundle actually goes back toward the motor, and there's a place down there all this has to go. And again, it's in a little bit of a smaller piece of conduit, but it's in a separate place. So that's next. Let's fish some wire. So to pull the wires through, I've got a fish tape, which is just basically this right here. This is for exactly what we're going to use it for, pulling wire. I'm just going to run that down the tube. We've only got a couple of feet of conduit, so it's not a huge run. Let's see if that's coming out down here. Oh yeah. So I'm going to take all my wires here that we got to pull through, and I'm just going to kind of tape them up onto this piece of wire here. In fact, I think I'm going to get a zip tie and zip tie it on there, I think. So I'm just going to run the zip tie through that piece of fish tape. We'll tie that kind of down below these other zip ties, so hopefully it won't pull up past them. I'll trim that off. And now I'm just going to kind of tape this up where it'll all kind of come up together. All right, see if we can pull that through. So I'm getting ready to put all my wires back in here in the order that they go. But before I do, I'm making one little upgrade. I started doing this kind of after I started building this, but as I've been pulling things out and redoing them, I'm putting these little ferrules on the ends of these wires. This is just a little crimp that goes on the end that kind of contains all those loose wires. There's a little tool here that you use to squeeze that together. It crimps that on there, and it just makes for a nice piece where you don't have stray wires and stuff, the wires fraying around in these little connections. So this one goes in the top one. That's number 38. So we'll put that one in. And I'm just going to work my way down. I'll go ahead and get this one tightened up. And we start with number 38 at the top and count down to number 30. I've also got all my wires marked here. I used a little printer I've got that does heat shrink wire wraps there where you can keep track of your numbers, and 38 goes to 38 on the other side. Trim this up. And just like that, I think we got all that tidied up. We got all our wires reconnected, run through the conduit like it needs to be. Got things wire tied up. There is a panel that bolts up over this and will cover up this whole area, so it will not be exposed in the final version. But I think we're good to go here. So that one's knocked out. I need to get my other wires going down to the motor pulled through and connected up. And we're going to take this thing for another spin and make sure everything still works like it's supposed to. It is slow and tedious work, but we got her done. I got all my wires hooked up back down here on this side. So I think I have got all the wires that we disconnected from the machine reconnected to the machine. And now the real question is it going to work after taking all my wires off and putting them back together? Should. I've checked and double checked all my wire numbers. Let's try her out and see how she does. I will start with hitting the power switch. We should see the lights come on. All right, so we see lights shining down there on our control board. That's all good. This will turn it on, hopefully. Forward. Check my variable speed. Stop. And reverse. Stop. And forward. I think we did it right. All right. Major milestone here. I got my electronics in the machine and everything seems to be working. So that is definitely a step in the right direction. Man, that makes me feel good. We're just taking another peek here with the drawer slid in with all the electronics in there. Everything's tucked away, out of sight, out of mind. And when the covers go on there, it'll all be protected. And it should be just fine, I do believe. So I'm real happy with how this is turning out. Again, I'm real happy with how this is turning out. I did get an email the other day from the gentleman that's been helping me with this project. He gave me a list of some things I need to do electrical-wise and test-wise and just fine-tuning and tweaking some things. I need to work through that, but generally speaking, I'm to the point where I'm pretty happy with where we're at. And the next big thing that we need to do, from making adjustments to our settings in the electronics as far as in the computer chip and all that, is we need to test it out under a load. And to do that, I got to get the machine put back together. So that's probably going to be really the next step in this thing, is to start working on getting things put back together. So that's going to mainly be getting the saddle, the apron, all the front stuff up on here where we can actually try it out. And I've got to decide how much rebuilding I want to do to that, whether it needs any scraping or whatever. generally speaking, this machine's in pretty good shape. So I'm not sure if I'm even going to fool with it right now. I might do just a little bit of tweaking. Like I said, until I start putting it together and testing and how things go together and get some feeler gauges in there and really looking at wear, I really just don't know. But like I said, it's in pretty good shape. This machine has seen relatively little use over the years, yeah, it's in pretty good shape all in all, I think. So that's kind of where we're at. Guys, with that, that's a wrap for today. Again, really happy to be moving a baby step forward on this. Hopefully, you know, like I have said all along, this has kind of been a back burner project for me. And it seems like so many times my own little projects in the shop don't always take precedence over work that I got to do that I'm doing for other people, unless it's a machine that I need for a specific job. And while this machine will definitely be a nice asset and a handy thing to have, it's not something that I've just had to have for a job. So it hasn't been a priority, unfortunately. And I'm hoping that we can find some time to get her finished up. Guys, with that, that's a wrap. As always, thanks so much for watching. Please, 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 if you haven't already, hit that subscribe button, subscribe to the channel. Hope to earn that from you. It really helps out a lot. Also, leave comments, thumbs up. They all help out a lot with the algorithms on YouTube and help me to be discovered by other people. As always, a big, huge thank you to those who support the site financially through Patreon, PayPal, and now also through YouTube memberships. You can join my channel through YouTube, and you pick in a little bit extra, not a whole lot usually, but if enough people do it, it really does make a difference. And you know, this is my job now, working in the shop and making YouTube videos. Really, my job is making YouTube videos now, and there's a lot that goes on in that. So I talk about that all the time, but it really does help if you can help out. So if you can, consider it, please do. And with that, we are going to get out of here. We'll catch you on the next video. Again, as always, thanks for watching.